attended the program down at Penn State, or State College. How I got a job at Intel was the same thing that I'm doing now, is that we had a recruiter come over from Arizona, the Arizona campus of Intel, come over and they checked out the program. Really liked what was going on at Penn College, so they sent a bunch of 2 or 3 people come up and interview us, right? On our 4th semester, ready to graduate. This is March of 2000, and at that time there were so many jobs in demand where I started a year later, right? I started in March of 2000, or actually, when did I start? March 2001, March 26, 2001. So at that time I actually took a job up in Massachusetts. So the Massachusetts campus, it's all 8-inch wafers. We were making, I couldn't even tell you, Pentium 3 processors at the time, maybe P4s. We ended up going to chipsets, and our factory was a dying factory. Back in 1998, Intel bought Digital, and Digital was one of the big companies making processors. Intel ended up buying them out. They ended up buying the factory. So at that time, they were going to close the factory down. A guy named Brian Kazanich came over. He was a factory manager. He saw potential in the factory, so the factory stayed open. Brian Kazanich now, who was a factory manager, is now the CEO of Intel, which is kind of cool. The fact is that, you know, I never met the guy because I started right after he left, but he pretty much gave me a job for 13, 14 years there. So the first 8 years at Intel, I was a technician, so I worked on multiple tool sets. What I mean by tool sets is equipment, right? So a lot of things that you're learning now will apply. So in the 2008, I got promoted into management, and then I was the equipment manager for about 3 years, 4 years, and I went over to operations, and I was an operations manager. I chose operations just as far as my own personal development because I wanted to get into more management. Equipment management was something that was a great step to where I wanted to go, and the operations side is, the fact is I wanted to get a broad spectrum, right? Managing people, managing the business as well. And managed operations equipment is just, it's very different. So I left Intel because Intel was closing down in Massachusetts, so it was a dying factory. So Intel didn't want to invest anymore in the factory because it was a small factory. If they wanted to put 300 millimeter in there, which is our 12-inch wafers, which we have currently throughout the world, we don't have anything higher than that. It would have cost Intel billions of dollars, and they didn't want to invest it there. So they started building factories out in the West Coast, Arizona, New Mexico, Oregon. They put one in China. They added more factories in Ireland, and then Israel. So I left there and went to Global Foundries, and Global Foundries, does anyone know who Global Foundries is? Do you know who Intel is? Do you know who AMD is? Okay. All right, so Global Foundries, it's a very, I would say, a new company. We started back in 2009. It was something that was a very new concept, or at least for the United States, is foundry business of making computer chips for other companies. So such as AMD. AMD had their own factories, right? And they said, you know what? We're out of the factory business. We want someone else to make our chips, right? And Global Foundries was created. And we are a foundry business. We don't own any chips. We just make them for other people. Intel, they make their own chips. They don't make them for anybody else. But they're starting to plan to get in the foundry business as well, because that's where it's at. The more advanced the technology gets, the more expensive it is for a company to produce that, right? They would rather just design a chip and go, here you go, here's my design, I want you to make the product for me. You can jump in whenever you want.
Oh, you're doing a great job.
Oh, thanks.
Yeah, like Pat's pointing to I think the business landscape, it's changing to a lot of companies are fabless companies. So even IBM, where I worked for 10 years up and decided to get out of manufacturing, and they paid Global Foundries to take over their manufacturing sites, because a lot of these companies are becoming fabless companies because of the large overhead to develop and build chipsets. So you have companies like us who, they just do the development, they hand us their plans, and we pump out chips for them because they need them.
So we're making chips for AMD, right? And they just made a chip. It's in the news. You can Google it whenever you get a chance on your free time. But we have one of the chips that clocked faster than any Intel chip. So, I mean, it was just one chip, but it's pretty cool. The fact is, we mean, you know, we've only been around for a very short time, but we mean business, right? So it's a very exciting time because we're in 300 millimeter production. There's up in Albany, there is a 450 site, right? So there's a lab up there. All the companies, you know, throughout the industry said, you know what, we're all going to get together and focus on 450 millimeter, right? Making a bigger wafer, and that costs a lot of money. Not one company can do it. Intel makes, I don't know what they made last year, but a couple years ago they made $40 billion in 1 year. So we're not going to do it ourselves. We want everyone to collaborate. So they're working on building a 450 technology, and they have a site in Albany, the nanoscale site, right? So there's a college up there, along with a brand new technology. You have all these companies at one specific site. And what's happened in upstate New York is that New York is invested in producing jobs, right? And there's a lot of tax-free incentives for big companies to come in and start their own businesses. And that's one of the biggest things. So you want to put you know, you guys know Silicon Valley, right? So there's a lot of things going on in Silicon Valley, right? But it's very expensive to build a factory out there. You know, Intel doesn't even have a factory out there. They used to. I think they're tearing it down now. As of this week or last week, they're starting to tear their old factory down. Fab 4. But it's very cheap up there compared to everywhere else, right? So this is all out the state. It's given incentives for companies to grow. So there's a lot of cool things going on there, which we'll go through in a presentation. Let's see, we make chips for, I mean, this is all public. We are a private company, but you know, as far as public stuff, we do make chips for AMD, and I was like one of our biggest customers. AMD pretty much, they are outsourcing. They're all looking for other foundries to build their chips as well. We're not going to be their one company that builds chips for them, right? Because if something happens to us, right, they want to make sure that they have a diverse portfolio for manufacturing for chips. But it's just a very exciting time for AMD. What else am I doing now? Anything besides what's in the presentation?
No, I think so.
So I have a presentation, and basically it's very brief. It's very informal, but it pretty much just tells you this is Global Foundries. This is where we're at. This is where our location is, and there's a lot of cool. Which I can't find that video on YouTube. I might have to look, but I do have another video I'd like to show you. The video I can't find is a video of showing what's exciting about Global Foundries and their location. I reside in Saratoga Springs, New York. Has anyone ever been to Saratoga Springs? So one of the biggest things in Saratoga Springs is I believe, the oldest horse race track in the United States. It goes back a long, long way. They have the horse museum there. Has anyone ever seen the movie Seabiscuit? All right, so a lot of the film, or some of the film was filmed up in Saratoga Springs at the track. So anyways, there's a lot of cool things up there. I really enjoy living up there. I lived in Massachusetts, like I said, for 13, 14 years. And I enjoyed living in Massachusetts because I got to see the Red Sox win 3 World Series. Right? I mean, I only went to one game out of all 3 World Series, but I got to see him. I got to see him at least go through that. Which is pretty exciting. But upstate New York is really cool. It kind of reminds me of Pennsylvania. But you know, this area, because you could live in a city where there's a lot of people, and you just get out of the city and all you know, there's farmland everywhere, and it takes hours to get somewhere, you know, to another city. Massachusetts was a little bit condensed. There was like a main street every mile, so there's traffic everywhere. So it's a nice place to live. Jason, you were from IBM up in Vermont.
So in Vermont,
And then,
it's come along quite a bit. You should take some time, Google the area. Saratoga's grown up quite a bit, and then I live closer to Albany, so I'm south of the Fab. But Patrick made mention to the IBM Nanoscale, or the Nanoscale school in Albany Nanotech. Is that what they call it?
yeah, Albany Nanotech. Yeah.
I remember when they first put that building in, it was a small building just off the 90, and now it's huge. They've tripled the size of it, I think, in less than 10 years. So the area is investing in semiconductors, and it's investing in industry. We've attracted other companies that came in because we're up there now.
Yeah, so we have a ton of jobs right now open. You know, you guys are all freshmen, with the exception of you, Norman. But, you know, I graduated from here, so I wanted to come back. I know you guys have a big program here. I mean, being a freshman, it's your first semester, you know, congratulations, you know, getting to college, and you guys have a lot to learn. And I would come down here every year if I had the opportunity to hire from here. You know, we hire technicians, right, with tutors, right, we hire engineers, you know, from electromechanical, right, to material science. You know, there's a broad band of skills that you guys will learn in class that that would apply to jobs we have up in GlobalFoundries. IBM, how much did IBM pay GlobalFoundries to take over the manufacturing?
It was $1.5 billion.
So IBM wanted to get out of the business, right? Like, we just want to design. We don't want to manufacture anymore. We are too. Our scope is too large. We're spending a lot of money in manufacturing. So they paid GlobalFoundries $1.5 billion to take over the manufacturing. And GlobalFoundries is like, okay, because what comes with their manufacturing is all their intellectual property, right? All their patents, everything else. And GlobalFoundries, huh?
And their customers.
And their customers. So GlobalFoundries has a huge portfolio, because IBM's been around for a very long time when it comes to manufacturing. And you know, when you get all the IP and all the customers and everything else, it just makes GlobalFoundries work that much more, and people want to invest in them. So let's go over the presentation. I have a video too. It's on YouTube with you know, video of inside the factory. We'll point out things that we focus on. I'm a senior section, actually, I should go through this. I'm the senior section manager in automation. And Jason's one of the section managers. Jason also started off as a technician, right? So we'll point out what we focus on in automation. So it's pretty cool. And then after these slides, and then we'll just go from there. Does anyone have any questions right now? Okay. This is my first class this year to do this, so you guys are. Fire away, okay? Because that means you can be more prepared if you guys have questions that I may have answers for, okay? So don't be shy. All right, so here's our locations. We're in Jason, you want to control this?
Sure.
Has anyone been to Singapore? Neither. Has anyone been to Dresden, Germany? No? It's a beautiful place. I recommend that you visit Germany, yeah. So, and we're right here in Saratoga. And that's our factory right there. So we have about roughly,
Sorry, Pat. Why didn't it stay in your slideshow?
put on that. Yeah. All right. So we have 400,000 square feet of manufacturing space, right? It's fairly large. If you can kind of see the cars up there, you know, that's how big it is, right? Within that 400,000 feet, we have 2 floors of manufacturing space as well. And they're all interconnected by automation. You know, we have roughly 12 miles of track on the ceiling.
14, I think it is.
14 miles of track on the ceiling, you know, 500 plus vehicles, which you'll see in the video, moving around, just delivering product. So we'll go through that. So we do have offices in Silicon Valley, Austin. Our headquarters is right here in Silicon Valley. Office in Munich, you know, China, Japan, Dubai, and Taiwan. All right, so this is Albany, right? So we're way down here at Penn College right here, about 5 hours, all right? Is anyone from New York? What part?
Festival Binghamton.
Okay, so you're not too far away, about an hour and a half, 2 hours?
From Binghamton to Binghamton.
Okay, all right, so it wasn't a bad, how long was the drive to Binghamton?
About 2 hours.
2 hours?
It's 118 miles from Albany.
So you're right about here, somewhere. So as far as Albany, so this is our technology, so this is pretty much who we have here. There's their universities here, and here's all the material suppliers and our companies, Applied Materials, ASML, Tokyo, Lam, KLA, Tencor. When you build a factory, you need companies to support that factory, right? And when you build a factory, more and more companies build up. So it's a very booming business right now. Because you just can't have a company run itself. You need other companies to help run it as well. Also, you have a lot of good colleges up here as well. So Binghamton, Cornell, RIT, University of Buffalo, Clarkson. UMass Amherst is on this side, but they're only a couple hours away. SUNY College in Annisco, which we kind of went over. Okay. All right, so we're centrally located, right? It's not a bad drive. So it took us about 5 hours. This is 4.5. It was roughly 4 or 5 hours. I think we got. It took us to get down here. But as far as I like this slide. Does anyone ski? All right. So we have the New Yorker who skis. What's your name?
Adam?
Adam, okay, Adam likes to ski. So Adam, we have tons of skiing, upstate New York, Vermont, New Hampshire. I was just in Maine, where you see that last skier up there in the very top right. I was just in Maine this past weekend fishing. So there's just a lot of cool things up there. There's a lot of good things to see and do. So it's a very good location to live and work. Community. This is what I was talking about before with the horse racing. So we had, last year we had a Triple Crown winner. First time we had a Triple Crown winner for a horse since the 70s, right? And that was Secretariat who won. So we had American Pharaoh, who was Triple Crown winner last year. And he came up to race at Saratoga. And they say it's the graveyard for champions because every champion goes there and they lose. So he came up, you know, one of the fastest horse, or the Triple Crown winner coming to Saratoga. He ended up losing a race. So we ended up getting second. But so it was cool to see a Triple Crown winner race. We have water everywhere. There's lakes everywhere. Lake George, Lake Saratoga Lake. We have obviously mountains. We have a great nightlife as well. So Luther Forest, you can see our Fab 8 campus right here. So that's an old picture. That was when we were under construction, right? So we're surrounded by trees. So it's very rural, and then you have a factory in the middle of the woods. So, and that's what it kind of looks like now. We have another factory right here. Back here you have the facilities, and the facilities that's what supports the factory for electrical and chemical. Go ahead. That's what it looks like now. So if we were to expand, which it could be any time, maybe 2 years, 5 years, 10 years, this is what the map looks like. So right now, all this exists to the left. This factory would be created, and we have another hub to support this factory. Okay. So inside of a factory, so it's a clean room environment. You have airflow. So you have all the air coming in from the top. You have the manufacturing space right here. So this is a clean room. You have all the equipment here. You have air return coming through. So basically it's just a big cycle of air going through filters. So it's the cleanest as possible. So when you get inside the factory, you're wearing these bunny suits. Does anyone ever see pictures or video of the clean room? So you're in these bunny suits that help protect the wafers from getting exposed to particles. All right, because we are, you know, we're humans, and I guess the biggest contaminant would be a human being in there.
We're the largest contaminator in the fab.
Yeah.
It's human beings.
All right, inside the clean room, this is what it looks like. Do you have a good view of this?
Yeah, I'm good.
Okay, all right. So this is what it looks like. This is what a bay looks like. We'll go through more of that. You'll see some video. And you see here's some technicians. We have an equipment team here. You know, they have laptops, probably writing some equipment logs, writing what work they did, you know, for the day or at that specific time. The documentation is very important. All right. And then we have production line here. So we have technicians here monitoring production. We have to have so this is the guys who run the operations, make sure that all the product going through the line is not being held up. Okay. As far as a typical wafer flow in a wafer factory, you can just click through this. So incoming wafer goes to fusion, and then you just have this big cycle that goes through multiple layers, and then litho is our I would say the most important module, because that's what gives you the specific pattern you want on the wafer to make the transistors, okay, or make a specific letters. So lithography, it's called a lithography. So what that is, basically, you are exposing a pattern on the wafer, right? And then you wash away the unwanted areas of the wafer to have this pattern, right? And then the pattern pretty much goes through this whole entire process to make your billions of transistors on the wafer.
Does
Can you
anybody,
talk a little bit about your quality control and use SPC is incorporated everywhere? We're just about ready to do an Excel project with SPC, so that maybe.
Jason, I think you should talk about SPC.
SPC.
Jason's very passionate about
Oh,
SPC.
good.
So I guess we, at least at our level, we have a tool called a wafer sorter, which takes wafers in, moves them from one box to the other, but it gets qualified on a 12-hour basis. So every 12 hours, we run blank wafers through it, and we take a particle count, and then we plot the points on a chart with the SPC chart and watch it trend. If it starts trending up out of the control limit, then the tool comes down and we have to get it back in to the control limit. So you monitor a couple different patterns when you start looking at it, where if it has 2 out of 6 fails or 1 out of 6 fails, it's based on Six Sigma. I don't know if anybody's familiar with that, but if it deviates a certain amount over the certain sigma levels, you counteract and take corrective action to keep the tool in suspend. The other thing with SPC is if it keeps trending low, it almost like it's supposed to set its own control limit to a point. So if you keep staying down low, you'll tighten your control limits up and keep. So if the tool keeps, if you're looking for, we call them adders, so it's additions to the wafer. So we do a pre-particle count and then a post-particle count. And then the difference is how many adders we're adding to the wafer. So if your adders are staying low at like 1, and your upper control right now is 15, but it keeps staying low at 1, you'll probably bring down your upper control limit and tighten it up to keep the tool running at clean.
Right, and you use like the process capability calculation to have an overall view of how things are going, right?
Yeah, and we have a bunch of tools at our disposal. So like, if you have a wafer, get a high count, you can see how many adders were on it. But then you can go further than that because they take a picture of it, so you can see what it looked like before, what it looked like after. You can start looking for patterns because the wafer's all handled by robots. So if the robot starts deviating out of its way it's supposed to be running, it might start